We are virtually flying back to Estonia for a presentation by R8 Technologies, and Ahmet Köse, the floor is yours.
All right, so I will start sharing my screen and hopefully everything will go fine there. All right, everybody, my name is Ahmet Köse. I'm a co-founder of R8 Technologies. Today, I will be talking about our experience during the pilot project, especially to impact to our product. So firstly, I would like to start with the product overview. What is our product about? R8 Digital Operator is a basically AI-based solution to adjust the heating, ventilation, air conditioning system set points in the large commercial buildings, regardless of their building automation system. Can be Siemens, Niagara, Schneider, Fidelix, Sauter, Wonderware, etc. So it comes with a remote setup. And then the solution itself is a software as a service, so it's not coming with any hardware or any kind of dependencies. This is a cloud-based solution, and it follows simply two main KPIs: energy efficiency and comfort indoor climate. We basically follow the shared savings model. What does this mean? Obviously, we start with the integration, meaning the digital transformation of the building. Afterwards, once we do see what are the points or set points meaning for us, then we start monitoring the product, the building. After a few weeks, let's say up to a month, integration plus diagnostics are completed, then we are delivering our diagnostics report, which means how the mechanical conditions and operational performance of the building is. If mechanical conditions of the system, HVAC system, is fine, we start our autopilot or the intelligent autonomous control. The savings starts from the day one, but we move control gradually. So by the end of the second month, we shall be able to control any possible set point or any possible subsystem in the HVAC. And then we move on with the monthly reporting, meaning that in every month, the building owner or building manager receives the KPIs of their building together with R8. And then what we do is that sharing the savings 50-50 with the building manager or building owner. So in this regard, the data aggregation actually is the key to measure the KPIs for R8 Digital Operator. So from indoor climate perspective, what I would say is that it's possible to collect the sensor data, what is available within the indoor climate, let's say in the room areas, temperature, CO2, humidity, whatsoever is available. Otherwise, it is possible to aggregate this information to indirectly with the return temperatures or whatever is available once again. In a worst scenario, we do recommend or request from the building managers to install some sensors or contact the maintenance company to do it. So from this direction, we can make the aggregation of the indoor climate data based on either the standards like a H3, S1, S2, Finnish indoor climate, etc., or building manager preferences or tenant preferences. So what we are saying that we are providing a flexibility for each building to follow up their own indoor climate policy. And then what we are doing is that following the KPIs of the indoor climate to make sure that the need or expectations are going to meet. So this is the chapter one from the indoor climate perspective. From the energy metering data, what we are going to do is that we are trying to optimize all the HVAC systems and then providing energy efficiency, and how we can validate this information obviously with the energy metering data. This is the most accurate and most objective information that we can collect, and we can compare with the degree days or the base year or savings, etc. But the metering data is the number one key here. In some areas, in some buildings, the metering data is connected to automation system, and we can directly connect it. But again, this is not a 100% case. In this regard, what is really important for us is that collecting all this metering information from one reliable and convenient source, and then in addition to other it doesn't have to be only electricity, it can be heating information or other energy-related information to commercial buildings. So here, where this data pilot project, the importance of it starts for us. But then, all in all, what is most important here is that the understanding two main KPIs, sometimes they conflict, meaning that to make sure that indoor climate is good, you need to make more energy consumption even than before. And then again, that this is really complexity where the R8 digital operator is actively working. So let's come back to now the data pilots project. Our aim was the transparent overview for the facility managers towards HVAC. Previously, it has been difficult to understand all the technical conditions and systems for especially non-technical managers. What we have done is that we create a building management tool for facility managers to steer their building between the indoor climate, expectations, and energy performance. And then we already shift our direction from test environment to live environment in Elering. So we are expecting that within a week or two, we will be able to connect to live environment. So meanwhile, we already contact with our clients, especially in Estonia, that they are going to give us access for their energy metering data. So which means already the other side of the business is already waiting for the technical side. And all in all, what we aim to do, automated reporting tool for transparent overview, we made it happen. So what comes next is that getting the information from the SPIT or Elering side, and then aggregating this information only from one channel. So present, what we have is that two KPIs comes together with our monthly report or transparent overview, and it delivers to facility managers. And then we do make it happen in every month. And then this is also some of the comparison of the previous months, so we can actually see how well the building is performing compared with the other months. And what will come after today or after this data pilot ends, we basically will ask from all our buildings or all our clients to connect to Elering. So which means that we assume more than 30 commercial buildings, large-scale commercial buildings like shopping malls and office buildings and hotels will be connected there. And then once we do have able to control let's say that big power or energy, which means that we are going to shift the energy load based on the demand or maybe demand response. This will show up. So this is very short introduction of what we have been doing and what we are planning to do. Thank you for your attention. Any questions?
Thank you, Ahmed, for a very motivating vision of how buildings will contribute to our energy future by consuming when there's a lot of electricity and not consuming when there's not enough. I have a question for you, which is relating to, in your demo you show, when you're talking about controlling HVAC, the ventilation and cooling and heating, it seems like you need a lot of different sorts of sub-meter data and control signals. And so my question would be, is there something that R8 can do with just the smart meter historical data, or do you need in your systems all sorts of other sub-meters also, or can you do something already if you have from some location only the historical consumption data?
Right. Starting with more or less 40% of the energy consumption in the large commercial buildings come from HVAC systems. And then, indeed, if there is a sub-metering information is available, we can use this information to present what is the impact of our control, and as well as to understand the anomalies of the subsystems. As an example, if there is any kind of the valve is leaking, or there is some operational inefficiencies for ventilation machines, for chillers or circuits, then we can basically aggregate this information with the sub-metering data and provide waste of energy. And the same thing goes with the indoor climate. that the systems are working inefficiently, they are causing waste of energy or waste of consumption, plus they are also impacting negatively the indoor climate. So in this regard, the more data, more sub-metering data is brings us a more efficiency. And also historical data already gives for our machine learning algorithms preset or pre-configuration to train our models so we can increase efficiency faster than how we do it individually.
Much for a thorough answer.